All right, guys, thank you for coming back. We are recording. If you're trickling in, that's okay. We're going to start. Okay. So, guys, we have already talked about some of these things. Okay. So they're saying this angle theta is in the second quadrant, theta is in the fourth quadrant, and this time they're going like this. Okay. Which is they're going clockwise. If you go from here to here, this is the initial side. This is the final side. Theta is this angle. It's in the third quadrant. It's kind of we went over. In the context of the previous example, we went over this. So nothing serious. By the way, we're still in chapter 2, section 1. And okay, this is important. Okay, guys, you want to understand this. And you're going to see it over and over again. All right. So when you start with the terminal side, you can go one full revolution. That's a full circle. That's 360 degrees. You can go a quarter. Okay, it's a quarter revolution. The whole thing will be one full circle. You went only a quarter. It's 90 degrees. And what's a half revolution? From here to here, that's a half revolution or 180. So let me show you on this. All right. So quarter would mean what? So you start from here. You start from here. You go this much. You went a quarter. Okay, this angle is 90 degrees, and this is 1/4. This is 90 degrees. This is 1/4. All right, you can also go half a circle. Half a circle would be something like this. I'm going to start again where I was originally, right here, moving on the circle. This blue dot is on the circle, and this angle is half a circle, which is 180 degrees. All right, and since I am going counterclockwise, it's all positive. Now I'm going to go like this. This is 3/4 of a circle. It's going to be 270 degrees. And if I make one full circle from here all the way, if I come back to my original place, I went one full circle, and that's going to be 360 degrees. Any questions on how we calculate the angles as we move around the circle? Again, I'm repeating myself. This is called the initial line. And then this is the final position, initial position, and wherever you stop. That's your final position. And the final position and the initial position can match. If you start here, go around all the way and come back, that's going to match. Any questions from anyone? Feel free to ask. Can't see you, but I can always hear you. So it's a little bit of repetition. Okay, this is not a good, bad example, guys, okay? So let me grab this little slide and put it here. And so 405. So how do I draw something like this? The vertex is the center, okay? 225. Now, I don't have to be really perfect. So 225 would be 90, 180. 225 is going to be about here, I would say. I'll tell you why. This is 180, but I want 225, right? I want 225. Let's write it down here. 225 degrees. Okay, so 225 is what? I can count by 90. Okay, in trig, we tend to count by 90. I'll tell you what I mean in a second. Okay, so 225 degrees will be in the third quadrant. How do I know? Well, this is 90. This is 90. That's 180 plus 45 is 225. So this is 45 degrees. Not a bad drawing, right? This is about 45 degrees. So what I'm more interested in is not exactly where it is, but in which quadrant is this line. Okay, this line, 225, will be in the third quadrant. What about 405? 405 is even more than 360. So 405, where is your terminal side? It could be a perfectly valid question for angle 405. Your terminal side will be in which quadrant? So let's find out. It'll be a valid exam question for you guys. So 405, let's take 405, write it right here. I want to ask you, in which quadrant would this line be if the angle is 405? Now you have to see, remember guys, we said we count by 90. So 405 is more than 360. 360 degree plus 45 degree. And 45 is not a magic. It's connected to 90. It's half of 90. So take a look. So if I want you to draw a picture now, you will be given the exam online. So you won't be able to draw too many things, but you can write down the answer. So you're going to go, you start here, you go 360, which is 90 plus 90 plus 90 plus 90. Now, that's not good enough. You want 405, not 360. You have traveled only 360. You have to go another 45. Okay. Now, if you were to draw it, how would you draw it? You would do something like this. You're going to go like this. Do you see it? There's a little overlap. That means you made a full circle and then you came back 45 degrees. So this is 45 degrees. And let's write it down nicely. So this angle, it's really 360 plus 45. And I'm going to write 405. Well, I used the wrong text box, but we'll fix it. 405. I'm going to pause here, see if you have any questions about how to label 405, 406. I won't give you 406. It'll be a nice multiple of 90. Generally, in trig, we see 45 degree, 90 degree, 30 degree, and 60 degree. As we move on, you're going to see we won't just give you 32 degrees, 33 degrees. We won't. So it won't be too bad. Any questions from anyone? All right. So just to let you know, I'm kind of repeating myself like in class. At this point, I will give students some activities and I'll walk around and see what they're doing. So it's a little overwhelming for our students and for us to teach things online because there's a lot to share. So I'm going to go on, do a little more work, but you do want to go home after the session is over. It'll be over around about at 11. And you want to practice some of these. The good news is the exam will be open book and the videos are available for you to watch twice, 3 times, 4 times. So it's a trade-off. So let's see. Any questions? Just turn on your mic and ask away. But can you explain this? Can you explain that? All right. I'll pause a little bit here, okay? Just a little bit. All right, guys, we're wrapping up. We're not doing too bad. All right, guys, so this is going to throw you guys off a little. Well, no, I'm not going to worry too much about it yet. But yeah, we're going to go over something a little complicated. Okay, so bear with me, guys. All right, so this is something you have done in 7th grade. Okay, and you kind of know, but you have to remember or recall this. All right, area of a circle. I have a circle. The radius of the circle is r, okay? This formula gives me the area of the circle, pi r squared, and this formula gives me the perimeter of the circle, 2 pi r. What is the perimeter? Is the length of the outer boundary. Okay, that's the perimeter. What is the area? It's how much it covers. And that's the area. You kind of have to remember the 2 formulas, okay? And you write it down. I'm going to change the color so that, well, the color didn't go well. I didn't mean to change the whole thing, but it doesn't matter. So area is the length of the boundary. Sorry, area is what's inside, and this is given by pi r squared. Perimeter is the boundary, length of the boundary, which is 2 pi r. What is pi? Pi is a number, That's approximately equal to 3.142. Okay, you do have to know these two formulas. You want to write down, I would encourage you to have a little notebook where you write down the important formulas, so you will have access to them. How you take your notes is kind of your business. When you study the book, you can take screenshots and save them in a Word document. That's one way, but here it is. So these two formulas will come in handy. Not only that we will use these two formulas, we're going to kind of go beyond these two formulas. Let me see if I can go over this again. I'm just trying to make sure I'm being recorded. Yes, I am. So guys, this is the area, how much a circle covers. If you had a circular carpet in your living room, how much of the floor will be covered? This is given by this formula, pi r squared. Pi is this, just a value, it's just a number. Perimeter, what's perimeter? Let me get rid of this because now it's a distraction. Perimeter is the length of the outer boundary. Well, what's that supposed to mean? All of this length. If you took a measuring tape and went all around the circle of your circular carpet, how long would it be? That will be given by 2 pi r. But that's not all. This is something you've done in middle school. So we're going to go a little beyond that today. All right. Now this, people find this a little challenging, guys, okay? Now, I'll try my best to explain it, so be a little patient. All right. All right, guys. We measure angles using two units. One is radian, one is called degree, and you guys know what a degree is. Okay, we talked about it, and I know you guys know it. Radian is something else. Okay, we're going to measure angles in two ways. One is degree, which is fairly straightforward. Okay, this is 90 degrees. Let me get rid of this, just a distraction. All right, which is 90 degrees. This is 90 degrees, okay? This is 180 degrees. I'm starting here, 90 degrees, 180 degrees, sorry, 180 degrees, 270, 90 plus 90 plus 90, and 360, okay? Now, radian is a little different, guys. Radian is a little, I'll define it. Radian is, it'll really, it throws everyone off, but I'll teach you a little trick that you can stick to, and they'll keep everything straight. All right, so suppose you have a circle here, okay? And if your radius is r, and your radius is r, and you move this much so that this length on your circle is also r. If you can do that, it's a little hard to visualize, guys. If you can do that, this angle is 1 radian. This angle is 1 radian. That's the definition of radian. I'm going to go over it again. Okay, 1 radian. All right. So what's 1 radian? How do you measure? It's about 60 degrees, but I did say about, okay? So it's not really 60 degrees. So it's 1 radian. What is 1 radian? If you take any circle and move the radius, start from the initial side and go initial position, initial side, and take your radius and go this much. What's this much? So that this arc, this a part of a circle is called arc, A-R-C, A-R-C. This arc is 1 radian. This arc is 1 radian. If this is r, same as this r, this angle will be 1 radian. Now, how do we keep it straight? The best way to keep it straight is to remember this little formula, okay? Remember, pi is just a number, about, pi is about 3. Let's write it down. Pi is about 3.142. Okay. Now, this angle, you can mathematically show that pi radian, 3.142 radian. I'm going to write it down very nicely because it's a little hard for first people who are studying trig for the first time to keep it straight. So we're going to say pi, sorry, we'll fix it. Pi radian is equal to 180 degrees. Okay, this is something you can keep straight. Okay, it can be shown that pi radian, I know this is about 60 degrees, and it kind of makes sense why I'm saying that. Pi is 3.142. So about 3 radians, I know it's 3.142, about 3 radians is 180 degrees. Now we won't say 3, that would be incorrect. We will say pi radians. Pi is a number, 3.142. To make matters worse, we generally don't put, there's no symbol for radian. Since this is our first day, I'm writing radian. We don't write radian. We tend to write this little thing as follows. What you will see is more like this. Let me get rid of this. I need the room. Okay, this is totally fine. I'm going to write it like this today. But if I say if I write it like this, I mean pi radian, it's another way of measuring an angle, is 180 degrees. And this little circle on top is degree. All right, it's called degree. And that's easy. Everybody knows that. And you want to write it, okay? Otherwise, it's like 180 books, 180 something else. So when you're talking about angle, angle can be measured in two different ways. One is radian, and the other one is degree. You guys are familiar with degrees, no problem. Radian is a little hard. This is how we kind of defined it. And if this is R, and this arc, this curved part of the circle is also R, this angle is going to be a radian. It doesn't matter how large your circle is, it's going to be the same. And you can mathematically show that when you come all the way from here to here, 180, this angle is 180 degree, and this is exactly pi radian. Okay, if you remember this relationship, you can solve a bunch of problems. And we're going to tell you some of the problems that I have assigned from your book and from MATLAB that pertain to these things. I'll do some of them actually for you now. But let's pause here a little bit, guys. Let's see how we are doing. Any questions at this point, guys? All right, let's see if we can solve some of the problems. I think I'm kind of done with chapter 2. Oh no, I am not done. I'm not done. Let me think. Let me think a little bit. So guys, this is a little difficult, but I am gonna save it for next class, which will be Monday. It's not that difficult, but I don't want to do it right now, okay? So let's go look at some of the problems from your book. Let's see if we can do some of the problems. That'll kind of help you understand what it is that we're doing and those things. Okay. Okay, right here. We can handle it. All right, so again, another important point, guys, when I give you online exams, I will use this kind of language, okay? So make sure when you do the problems from your book, from MATLAB, do read the text above the problem, okay? So this one says, convert each angle in radians to degrees. Let's do some of those. Now, I did assign you a bunch, like 35 through 58, like 3 sections. I'll do a couple from each, no big deal. If you have a preference, you can always say, could you do number 38? Could you do number 37? All those things, you can do that. Let me do number 38, okay? Again, this is given in radian. This will have to be converted to degree. Bring this guy here. This is again 2.1. I'm going to save this here. So that little box, I'm now going to delete. This relationship is very important, okay? I'm going to write, we are working on 2.1. This is because we are recording. I'm going to write 2.1 here so that you know when you watch it. This is the section we're working on. Again, the text goes here, or it is here. This is what we're doing, convert each angle to radians in degree. And these are fair exam questions. So I'm going to start with this. Negative 2 pi, I'm kind of copying the question, over 3. So I'm going to convert it to degree. Instead of pi, I'm going to write 180 degrees because pi radian is equal to 180 degrees. Just to let you know, it's a little awkward to type here, but so all I did is replace pi radian with 180 degrees. Why? Because they're the same. We know it. We have established it right here. Give me 1 second. I'm going to write it properly. Okay. Now I'm not done. I have to do some cancellation. Okay. I can divide 180 by 3. I'm going to get 60 degrees. And that's what I'm going to write here. Right? $180 divided by 3 is 60 degrees. And 60 degrees times 2, and don't forget the negative sign. There is a negative, don't forget it. 60 times 2 is 120 degrees. And negative 120 degrees, because that's a part of the question. So that's how you're going to solve this problem. You should be able to do all the other problems in this section. There's not a whole lot to it, except for wherever you see pi, you replace it with 180, because pi radian is equal to 180 degrees. Okay, guys? Let's do a couple more. So you really shouldn't have trouble with these problems. I don't see why you would. All of these, just replace pi with 180 degrees and solve. Now, this one is interesting. What are they saying? Convert the angle in degrees to radian. So these are given in radian. Sorry, degree. And you have to convert it to radian. Let's take number 50. Let's take number 50, which is negative 51. Which is negative 51. Let's bring it here. Still 2.1. All right, so if 180 degrees is equal to pi, based on this, if we divide both sides by 180, it's another relationship you can actually remember. If I divide both sides by 180 degrees, what do I get? I get this. Okay. Now, 1 degree is very tiny. Okay, it's a tiny size of an angle, is equal to pi over 180 radian. So 51 degree will be this number times 51. If 1 degree is this, you can multiply both sides by 51. I'm showing you the details here. If you multiply both sides by 51 or negative 51, you're going to say, okay, you're going to multiply both sides by negative 51 because that's what your question wants you to find. And if you multiply this by negative 51, you're going to get negative 51. If you multiply the left-hand side by negative 51, you just write negative 51. Now you can cancel here anything. So this is your answer. This is your answer. Okay. So again, how did I do it? Let me go over it once again. I have to know this. Pi radian is 180 degrees. If I divide both sides by 180, I can also remember pi over 180 radian is 1 degree. Okay. Once I know that, whatever angle they want us to find, we're going to multiply both sides by 51 or negative 51 here. And the left-hand side, whatever you get, is your answer. If you were to cancel a few things, you would, but I don't think you can cancel much here. I'll do one problem where you have to do some cancellation. How are we feeling, guys? Feeling okay? All right.
Yes.
Awesome. I know it's a little rough. So guys, let me do this 350. Okay, let me do 52. Same technique. Same technique. Number 52. I'm going to convert this angle to, it's given in degree. I can see it. I'm going to convert it to radian. I'm going to start with this. Pi radian is 180. I'm going to divide both sides by 180. That step you'll have to use for everything. But here it's 350 degrees now. 350, it's 350 degrees. So basically you're going to multiply the right-hand side by 350, the left-hand side by 350. And you have to cancel. So I'm going to save this here. I'm going to rewrite or copy the box. So how do I cancel this? I can cancel the two zeros. That's good enough. And that's your answer. I can't cancel any more. If I could divide the bottom by 5, I would divide the top by 5. 35 divided by 5 will be 7, but the bottom is not divisible by 5. So my answer is 35 pi over 18 is radian. Okay. All right, let's see what else is going on here. So convert each angle to, this is interesting. I'm going to do some of these, okay? Guys, it's kind of the same thing, but it seems, so you have to read the question. It says convert each angle in radians to degree. This is in radian. Okay, I'm going to do 54. This is already given in radian, 54. How do we do that? So I'll take this, save this here. This is in radian. All right, exciting. So kind of similar to what we did, guys. So pay attention. Similar, not identical. So I'm going to start with this by radian. Okay, this is in radian. Okay, so I'm going to divide both sides by pi. If I divide the left-hand side by pi, I'll get a 1. And I'm going to divide the right-hand side by pi as well, because if you divide the left-hand side by 1, you have to divide the right-hand side by 1. So now from this formula, pi radian is equal to 180 degrees. You can say 1 radian is 180 over pi. All you have to do is you're looking for 0.75, you multiply both sides by 0.75. If you multiply the left-hand side by 0.75, you're going to get 0.75. If you multiply the right-hand side by 0.75, you're going to get this. Now, let's go over one tiny thing here. One tiny thing. So you're almost done. But you have to use your calculator to find out 0.75 times 180. Now, in a face-to-face class, I would ask you to have a graphing calculator, but it's an online class, and you can always use Desmos. We're going to use Desmos a lot. Okay, Desmos. You go to Google, type Desmos, and you can go to Scientific Calculator. And this is a calculator, 0.75 2.75 times 180 gives me, of course, you can use your handheld calculator, no problem. I'm getting 135. So done. I'll be happy to do one more like this. So just to let you know, let's see what's going on. Just to let you know, by the end of the day, today, you should be able to do some of the problems from 2.1, maybe not all. And by the end of the next day, which is Monday, you should be able to do all of them. And probably on Monday, we'll wrap up 2.1 and start 2.2. Let me do one more today. One more. So let's say, how would I do this? 7, number 55. Okay, number 55 is simply 7. Okay, I can handle that. And by the way, square root of 2 is just a number. Okay, don't let that bother you. You can do square root of 2. I'm going to go write the problem here. By the way, this is your answer, 135. So I'm going to go back, use the same strategy. I know pi times 180 is, pi radian is 180. I know that. I divide both sides by pi. I get something like this. I'm going to multiply both sides by 7 because that's what I'm looking for. So 1 times 7 is 7. And 7 times 180 is, I think I can do it in my head. What's 7 times 180? 700. I have my little pi, that's 700, 560, 1260. I'm going to double check on my calculator. Okay, I'm getting 1260. 7 times 180 is 1260. I hope that's right. 7 times 180. $12.60. That sounds about right. So that's that. Any questions? You don't have to divide it by pi. So that's what you're going to give me on the exam. On the exam, you have to write pi, you have to write division properly, and we're going to go over it. But let me see what else is going on in the problem section. Okay, this section, we're going to do it next class. So I'm going to stop here, if that's okay. I'm going to spend a little bit of time on this. We've actually had 1 hour session. I'll be happy to be around to take some questions. So again, let's wrap up a little bit. The video will be uploaded. You want to start 2.1, you'll be able to do part of the problems, not all of them. I will wrap up this section on Monday. Hopefully we'll start another section on Monday. We should be able to. Other than that, do you have any questions for me?
I
Okay,
do.
go ahead. I'm listening.
The questions that you give us, like how you got the thing where we do so many problems, for each section. How do we turn those? Do we have to like turn them in?
Okay, good question. Good question. So look, these problems I'm grabbing, are you talking about these problems?
Yes, I see where
Okay.
It says that we have so many to do for each section.
Exactly. Let me go over it. These problems are problems from your book, and they are here. Now listen to me very carefully. Okay, they are here. And I'm giving you more than what you're asking. I'm explaining more. So these problems are here. Problems assigned from the text. You don't have to turn in at all. You don't turn those in. You want to practice, you're fine. What do you turn in? That probably is your next question. You go to student links and you go to, by the way, if the computer kicks us out, you go to all assignments. You're going to go click this and you're going to work on these problems. Does that answer your question?
Yes, sir.
Okay, these problems are really parallel to what the ones I'm doing on the screen, on the computer screen. They're really parallel, but you do want to practice these. Once you practice them online, they will be stored there. And I will go on July 27th. I will look at what you've done. The computer will give you a grade based on which ones you got right. Now you can answer. If you mess up the first time, you can do it a second time, third time, fourth time, no problem. But you do have to practice. Does that make any sense?
Yes, sir, it does.
Wonderful. Any other questions from anyone? Just to let you know, this session will end in 4 minutes. We're kind of officially done. I won't always leave at this time. I'm going to get out of this session. I'm going to come back. I'm going to upload the video, but I'll be here. If you guys want to come back, have a little chit chat, one-on-one, you don't understand something I went over today, that's totally fine. You want me to show you something on the computer, you don't know where things are, I will be there. So I'm going to jump out of this session. We're kind of officially done. I'm going to come back and be available for you in order to take some more questions. Does that make any sense, guys? All right. If you want to leave, be my guest. If you want to come back again. I'll be here.